Hello, we are the team behind Ordo. My name is Andrei, and together with Denis and Sava, we developed this backend system to manage student projects. So, to ensure a reliable and reproducible environment for our application, we started with a solid infrastructure setup. We use Docker to run the necessary services. As you can see in this configuration file, we have defined a PostgreSQL service running on port 5434 and a Nginx container that acts like a reverse proxy for our application. To start the infrastructure, we simply run the command docker compose up -d. This gives us a clean, isolated environment in seconds. We have also documented the entire setup in our README file. Here you can find short description of the project, the tech stack, and clear instructions on how to start the application and run the tests using Maven. The core requirement for this project was a strict implementation of the hexagonal architecture. As you can see in our package structure, we have clearly separated the code into distinct layers to isolate our business logic. Everything related to the business core is inside the application package. This includes our ports, which define the interfaces, and the domain, which is the heart of our system. It contains our core logic and models and is completely independent of frameworks. Surrounding this core is the adapters layer. This is where we handle external concerns such as REST controllers and persistence logic. Finally, for our database schema, we use flyway migrations. All our database changes are versioned here in these SQL files, ensuring our schema evolves safely. These tables are mapped to our Java code using GPA entities, like this student GPA entity. We keep these entities inside the persistence adapter, completely separate from our pure domain models.
Hi, I'm Sava. I will walk you through the data flow of our application using the create indentation feature as an example. The request starts here in the indentation web controller. Crucially, the controller does not contain business logic. Instead, it calls the input port the create indentation use case interface. This ensures web layer is decoupled from the core. The implementation of this port is found in the application layer, specifically in the indentation service. Here we handle validation and business rules. When the service needs to save data, it calls an output port, like persist indentation port. Again, this is just an interface. Finally, in the adapter layer, we implement this interface in the indentation persistence GPA adapter. Here we use the entity manager to write to the PostgreSQL database. This completes the hexagonal flow. We also focused on performance here. For read-heavy operation, such as fetching project details, we implemented caching on the service methods to reduce database load. Here on the get method, we applied the cache result annotation. This tells Quarkus to store the return value in memory. Subsequent calls with the same parameters will skip the database entirely and return the result instantly. However, the data consistency is critical. That's why on methods that modify state like create or update, we use the cache invalid annotations. This ensures that as soon as data changes, the old cache entry is wiped and the user always gets fresh data. Now, let's verify this behavior and look at HTTP caching headers in Postman. First, I'll send a standard GET request to fetch the projects. Notice the flag etag header in the response. The string is a hash representing the current version of this source. Now, I trigger a state change by creating a new entry via this post request. Now let's go back to our get request with the old e tag and send it once again. We get a 200 OK and a new e tag. The system correctly detected the change and served the fresh data from the database. This demonstrates that our caching strategy is both performant and consistent.
Hi, I'm Denis. A major focus of our project was software quality. As per the requirements, our system must pass all tests during the build phase. I'm running Maven Verify with flag not to skip integration tests now. We implemented comprehensive integration tests using the Quarkus integration test annotation. These tests spin up the application in a Docker container and test it as a black box. For example, in Inventation Web Controller IT, we simulate real HTTP requests to create, accept, and delete inventations. As you can see, the build is successful, and all integration tests have passed. Finally, let's look at the running API. We use Postman for documentation. I will send a request to fetch all projects. And here we get a 200 OK response. If you look closely at JSON, you will see that we implemented THWS. Each resource includes a self-link section. If we go to this link and make a GET request, then we will get links to update project, delete project, get milestone, get tasks, and others. This is how we implemented THWS. This allows the client to navigate the API state dynamically without hard-coding URLs. The system is fully functional and optimized. That concludes our presentation. You can find the source code link in our portfolio document. Thank you for watching.